Hello students, welcome to Edubbey Global Solution. Now mathematics class again, we're going to be looking at another topic which is further probability. You know, the previous class we looked at probabilities, and in this class we're going to be looking at how we can prepare our tree diagram and how we can draw more than two outcomes. So we have our interactive content that will serve as a guide for this class. Okay, so let's start with our combined events. Combined events look at the probability of two or more events. So when you have an event that is more than one, then we classify them as what? As combined event. Okay, so we have a table here. This table shows the two-way possible outcome of what? Of tossing two coin. Okay, so that table now illustrates how we can actually get outcomes. And we're going to be sketching that in a GV. So you know that a coin has either head or tail. So let's assume that the first coin we have head and we have tail for the first one. Now the second coin too, we have head and we have tail. So we can have the outcome in this form. Okay, so we have head, that is for the first time we can have head in the first one and head in the second one, and the second time you can have tail in the first coin and head in the second coin. Okay, now the second outcome can be head and tail. Then we have tail and tail, that is tail in the first coin, tail in the second coin. Okay, now they now say that what's the probability of getting two possible head. Now if you look at this outcome, how many do we have altogether? The total number of outcome is 4. 1, 2, 3, 4. So the total number of outcome is what? Is 4. So now answer what is the probability of getting two heads? The probability of how many times can you see two heads? This is just once. Okay, so the probability of getting two heads, okay, is what? Is what? Probability of getting two heads is 1/4. That's probability of getting two heads. Okay, so now for this one, now we said that the probability of an event is what? Number of favorable outcome over the total number of outcome, and probability of getting an head, which is just 1, is what? Is 1/4. So let's check and let's see what we have. Now they are cool. Now let's look at the next activity here. We are still having the coin and the head. Now they're telling us that what's the probability of getting a head and a tail after we close the coin. So look at this. This is a tail, this is a head, 1. This is a tail, and this is that's another one. 1 plus 1 is what? 1 plus 1 will give us 2. So the probability of getting the head and the tail is what? 2/4. Okay, but we can see that 2/4 can be reduced to the lowest term by dividing the numerator and the denominator by 2. So this divided by 2 will give us 1. Therefore, 2 divided by 2 will give us 2. So we have it to be what? 1/2. So the probability of getting a head and a tail is 2/4. Then we reduce it to the lowest term to have 1/2. Okay, so this is the network. Okay, now let's look at three diagrams. Okay, so under this I want to see how can we sketch our tree diagram, and easily we're going to be illustrating this diagram on how we actually can get a 3 coin toast. So when more than 2 combined events are being considered, then tree diagrams are a good way of what? Of presenting information using a diagram. So when you have more than 2 events, then we make use of 3 diagrams. Now if you look at what we have here, we are trying to illustrate 3 coins that is being tossed. So we have 3 coins being tossed, that is head and tail, head and tail, and head and tail. So we want to see the output. I want us to try it. We're going to be doing it together. Let's see the first toss, which is there. So let's assume this is head. Let's assume this is tail. Okay. Now for the second toss, we are going to have head and tail here, a tree here, and we are going to have a tree here too, which is head and tail. Now for the third toss, this is the first coin. Okay, first coin. This is the second coin. Okay, and the third coin now. Okay, third coin. We are going to have another head and tail since we are dealing with coin, head, tail. We are going to have head, tail here as well. We are going to have head and tail here as well. and we're going to have head and tail here. So with this now, we say we make the arrangement, then we can now bring out the output. So we read head, head, head. So the first one is going to be head, head, head. Okay. Look at the second, we have head, head, tail. So this one is going to be head, head, tail. Let's look at the next one. Head, tail, head. We have head, tail, head. Okay. Let's look at this head, tail, tail. So we have head, tail, tail. Let's look at this one. Tail, head, head. We have tail, head, head. Let's look at this one. This is tail, head, tail. We have tail, head, tail. Okay. Let's look at this one. We have tail, tail, head. We have tail, tail, head. Okay. And the last one is we have tail, tail, and tail. So we have tail, tail, tail. And that gives us the probability of tossing what? 3 coins. And that's the output. We can see it there. Okay. Now, let's use that. We've arranged that before in our previous illustration. So let's use the diagram that we have illustrated to calculate the probability of getting 3 details and probability of getting 2 head and 1 tail. We still have the illustration here, and we're going to be using that. So you see, the very first time, let's count the total number of this outcome. This is 1, 2, 3, 4, 5, 6, 7, 8. So the total number is what? The total number is 8. And remember, we are talking about probability of an event to be what? The number of favorable outcome over the total number of outcomes. So we are now saying that the probability of getting 3 8. Look at it in this outcome. The only time we can get 3 8 is what? It's just this. So the probability of getting 3 8, head is what? Is 1 over 8. Okay. Now the next one is, what is the probability of getting 2 head and 1 tail? So let's study it. This is, we have 2 head here, 1 tail. 2 head here, 1 tail. Let's look at it again. Is there any other place that we have 2 head and 1 tail again? Let's look at 2 head, 1 tail. We have 2 head and 1 tail here. So we have, let's count 1, 2, 3. So the probability of getting 2 head and 1 tail is what? Is 3 over 8. And that gives us the solution to this problem. So let's quickly try the right answer to the boxes. Probability of 3 heads is what? 1 over 8. Okay. The probability of 2 head, 1 tail, that is HHT, HTH, and THH. So we have it to be 3 over 8. Let's check our arrangement and let's see what we have. Okay. Right. Now let's look at this next tree diagram that we have here. This is an activity. We say that in the winter, okay, the probability that it rain in 1 day is 5 over 7. Okay, use the tree diagram to show that all the probability, all the possible combinations of the 2 consecutive day. So let's assume that it rain. There's no probability that it rain. The probability that it rain is 5 over 7, and the probability that it's not going to rain is going to be what? 1 minus, that is, probability of an event will not happen is 1 minus probability of an event will happen. That is 1 minus 5 over 7. Let's find the LCM. That's going to be 7 minus 5 over 7. That 7 minus 5 will give us 2 over 7. Probability of it will not rain is what? 2 over 7. So for the first day, we have the 1. We are going to draw our tree diagram. It will rain. Let's represent it as how. It will not rain. Let's represent it as n. So we have this to be 5 over 7, and we have this to be 2 over 7. So that's for the 1. Day 2 as well. For day 2, is either it rain or it will not rain. Rain, it will not rain. Okay, it will rain and it will not rain. So remember that we said that probability that it will rain is what? 5 over 7. Okay. Now, probability that it will not rain will be what? It's going to be 2 over 7 here. Probability that it will rain is what? 5 over 7 here. And probability that it will not rain is 2 over 7. So we are going to be picking these together and we multiply. So we multiply this with this. That is 5 over 7 multiplied by 5 over 7 to get rain, right? So that is what? That's 25 over 49. That is 5 times 5. Then well, we have 7 times 7. That is it will rain, it will rain. Okay, now let's look at probability that it will rain and probability that it will not rain. That is R, okay, Rn. Okay, that is going to be 5 over 7 multiplied by what? 2 over 7. 5 times 2 is 10, 7 times 7 is 49, so it's going to be 10 over 49. Now, okay, we are through with this one. Let's come here again. Let's look at the probability that it will not rain and probability that it will rain. So that is NR, okay? It's going to be multiplied over 7 multiplied by 5 over 7. 2 times 5 is 10. 7 times 7 is what? 7 multiplied by 7 will give us 49, okay? So that is 10 over 49. Now let's look at probability that it will not rain and it will not rain in the first day and in the second day, okay? So it's going to be 2 over 7 multiplied by 2 over 7. 2 times 2 will give us 4, okay? 4 times 7 times 7 will give us what? 49. And those are the possible outcome of the 2 days, given that it will rain and it will not rain. Okay, now we are now to calculate the probability that it will rain in both days. Probability that it will rain in both days. Based on what we have illustrated earlier, probability of it will rain in the first day, RR, and it will rain in the second day is what? Is 25 over 49. That is 5 times 5 over 7, okay, multiplied by 5 over 7, because it's raining in the first day and it's raining in the second day. That is 25 over 49. Now, let's look at the second one. So we said that we should calculate the probability that it will rain on the first day, but it will not rain on the second day. So let's look at this. It will rain on the first day, it will not rain on the second day. This is going to be the probability, okay? So it's going to be what? Probability is going to be 5 over 7 multiplied by 2 over 7, that is 10 over 49. Now, let's calculate the probability that it will rain at least in one day. So, what we just need to do is that we pick the probability that it will rain at least in one day. So, the first one is going to be probability of RR, okay? Probability, we are supposed to put probability in front of it, probability of RR. Then, it's rain and no rain, just one day. Probability of RN, it's rain, it does not rain and it's rain, and the probability of NR. So, if that is the case, what's the probability of rain and rain? That is going to be 25 over 49 plus what's the probability of it will rain and it will not rain? That is 10 over 49, right? And what's the probability of it will not rain then it will rain? That is 10 over 49. We have a common LCM of 49, so the common denominator is 49. Now the numerator is going to be 25 plus 10, okay, plus 10, okay, over 49. 25 plus 10, that is 35. 35 plus 10, that is 45. So we have it to be 45 over 49. So that is the probability that it will rain at least one day. Okay, now let's look at conditional probability. When you are talking about conditional probability, we are talking about an event occur given that the other event, when we have two events, one will occur given that the other one will not occur, or one event is actually depending on the other event. Now, let's look at this table that we have here. It is the number of boys and girls rather that study mathematics and arts in the school. Okay, so for the boys now we have 26 mathematics, 14 for arts. The total is 40. Yes, we have 34 for math, and we have 12 for arts, and we have 46 altogether. Then the total number of students that study mathematics is 60. Total number of students that study art is 40, and total number of students that study both math and mathematics altogether is 84. Okay, so we have to calculate the probability that they study what? They study mathematics. So we have to look at the number. We want to get the students that study mathematics. All we just need to do is calculate the number of students that study mathematics, which is 26 plus boys plus 34 girls. That is 60, right? And total number of students in that class is what? Is 86. So the probability of math, let me represent it with n, is going to be what? 60 over 86. Okay, so I think 2 can go here. If 2 goes there, 2 can go in 60. How many times? That is 30 times. And 2 can go in 86. That is 43 times. And that gives us the solution to that question. So let's click the right answer to the boxes that we have here. The number of students that study mathematics by the time you have 26 plus 34 will give us 60. Okay, the total number of students is what? 86, and 60 divided by 86 reduced to the lowest term will give 30 over 43. So let's check if you are right. Okay, let's see. All right, we are cool. Now let's look at the next question under this table. So we have to calculate the probability that they study mathematics, given that they are girls. So what probability that they actually study mathematics, that given that they are what? They are girls. So this type of situation is a what? Is a conditional probability. Okay. So we have let's look at how many girls. We have numbers of girls is what? Numbers of girls are given mathematics, that they study mathematics is 34. Okay, so the number of girls that are studying mathematics is going to be what? Is 34. And total number of girls that study that or the two subjects is what? Is 46. So the probability that they study girls study mathematics, okay, they study mathematics given that they are girls, is going to be what? The number of girls that study mathematics, which is 34, divided by the total number of girls in that class. So that is going to be 34 over 46. And that is the probability that they study mathematics, given that they are girls. Let's put the right answer in the boxes. We have 34 to the number of girls in the class. The number of students that study mathematics, okay, is actually 34. Then the number of students that study the number of girls that study mathematics is what? Mathematics is 34. Okay. Then the number of girls in the class is what? Is 46, right? So the number of girls that study mathematics is going to be what? 34 over 46. Let's check our answer. Now let's look at the past questions that we have here. We are going to be studying it together in the moment. Okay, so let's have it now. 12 students each answer 30 questions in a quiz, and we have their table here. So the number of questions they answer correctly and the time that they use to answer those questions. Remember, the total number of students in that class that answer that questions are what? There are 12 students. Though the question that has been answered is what? Is 30 questions. Okay, now, so they said one of the students is selected at random. Write down the probability that the student took more than 8 minutes to answer the question. So let's look at the time frame. What we just need to do here is like we look at the number of students that take more than 8 minutes. Say more than 8 minutes. That implies that it has to be 9 minutes upward. So let's count how many. We have 1. Okay, that's the first student. And is there any other one? We have 2, that is 9 and 10. So it's going to be 1 plus 1 divided by the total number of students, which is 12. So it's going to be 2 over 12. We can reduce it to what? 2 can go in 2 one time, and 2 can go in 12 how many times? That is 6 times. So we can have it to be 1 over 6. Okay. Now the next one said that the probability that the student took less than 5 minutes and have more than 24 questions, answer 24 questions correctly, more than that. So what we just need to do is we look at less than 5 minutes students that answered more than 24 questions correctly. So our target is 4, 3, 2, 1. Then for questions, our target is going to be 25 upwards. So let's check. I think under 4 we have 28, under 30 we have 3 we have 30, and under 2 here we have 26. Okay, anything after that I think is not okay. 7 is a no. Okay, so we have 3. So we have 3 students that use less than 5 minutes and we answer more than 24 questions. That is 3, 4, and we have less than 8. Okay, we have 4, we have 3, and we have 2 less than 5 minutes. So that's going to be 1 plus 1 plus 1. That is 3, right? So by the time we add them together, that is 4, 3, and 2. So we add them together like a student 4, another student 3, and another student 2. 1 plus 1 plus 1 will give us 3. Then divided by total number of students, that is 12. There's going to be 3 over 12. Okay. Now, what we have here, we have a tree diagram here. So this tree diagram is telling us that a bag contains 7 red sweets and 4 green sweets. Ahmed took out a sweet at random and eat it. She then takes out a second sweet at random and eat it. We have to complete the diagram. This diagram is supposed to pop up the solution. Let's see what happened. Okay, so we have to complete the trigram that we've seen below. Then with that, we have to calculate the probability that Amen has two red sweet and Amy has one sweet of each color. Okay, so if you look at it, we have the table here, the tree diagram here already constructed for us. So all we just need to do is what? We complete the tree diagram. Okay, so now what we have here is for the first sweet. Okay, we have seven red. We have seven red. The total number of sweets by the time you add 7 plus 4, that is 11. Okay, we have red sweets. Okay, and we have 4 green sweets. So we have 4/11. So for the first one here, okay, as they said that she then take out a second sweet at random and eat it. So what we need to do is that by the time we are picking up, we are going to be replicating and we are going to be reducing. Okay, so for the first one here, we have 7/11. So the red here is going to be what? 7/11, and green is going to be what? Green is going to be 4/11. That's the total number of so from here now, we are picking out without replacing. Okay, so the second one, we have to be subtracting this by 1 to have the red color. We subtract 11 2 by 1. So 7 minus 1 will give us 6, and 11 minus 1 will give us 10. So without replacing it back, that is what happened there. So we have 6/10 for red, and green is going to be minus we have -1, we have and we have also -11 here. So it's going to be we have under red here, then we are going to have 4/10, because we are reducing the denominator, that is, we are picking it without returning it. Now come here to green, we are going to be having 7/10 here. Okay, what do we have? We have 7 to be the red, then we are picking without replacing, so we subtract 1 from the original value, and we have here for green, we are going to have 4/10. So we are subtracting as well. Now we have to calculate the probability that she took 2 red sweets. Now let's look at the 2 red sweets that we have. 2 red sweets, we have 7/11 and what? And 6/10. So it's going to be 7/11 multiplied by 6/10. 7 times 11, that is 42, right? Divided by 10. 11 times 10, that is 110. If you can reduce this to its lowest, then we can divide 42 by 2, that is 21, and 42 divided by 110, that is 110, will give us 55. So that's probability for the first one. The second one says 1 sweet of each other. 1 sweet of each other. That implies that if you pick, it's going to be red green. Okay, red green and what? And green red. So that is 7/11. Okay, 11 rather, multiplied by 4/10. Okay, plus what? Plus we are picking green red, right? This time around it's going to be 4/11 multiplied by what? 7/10. Okay, so 7 times 4, that is what? 7 times 4 is 28, multiplied by 110, plus 4 times 7 as well is 28, multiplied by 110. 28 plus 28 will give us what? Will give us 56/110, because we have the common denominator. Okay, so let's divide this by 2. If we divide 56 by 2, we have 28. Divide 110 by 2, we have 55. And that gives us the solution to this problem. This takes us to the end of our class. We want you to subscribe to our channel, www.edubbey.com, for the full interactive content of this class. Thank you.